welcome to True Projects. In this video, we will be explaining about IT and multi-layer online resource allocation and offline planning in metropolitan networks. Introduction. Metropolitan networks are crucial for delivering high-speed, low-latency services to larger user bases. The increasing demand for data-intensive applications has led to the adoption of dynamic networking solutions to minimize latency and optimize resource allocation. This project proposes a novel method integrating software-defined networking, which is SDN, and network function virtualization, which is NFV, enabling flexible and programmable network control. The LA-ML-SCA algorithm optimizes service path selection based on latency-aware criteria, resulting in reduced latency for service requests. The approach is evaluated using the Net2Plan simulation library and a custom Python-based network simulator to assess performance on Spanish metropolitan network. The project review related works present fundamental SDN NFV concepts, details the LA-ML-SCA algorithm, and discuss simulation results. The project aims to enhance user experience and network performance, making metropolitan networks more efficient and responsive to evolving demands. Objective. The project aims to reduce latency in metropolitan networks by integrating software-defined networking, which is SDN, and network functional virtualization. It introduces the latency-aware multi-layer service chain location, which is LAMC-SCA algorithm, optimizing service path selection based on latency-aware criteria. The project simulates the approach using a Python-based network simulator and analyzes implementation costs. The goal is to improve user experience and network performance, making metropolitan networks more efficient and responsive to evolving demands. These are the requirements for execution of the project. In hardware requirements, operating system of Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above are required. In software requirements, Python IDEL of 3.7 version is required. These are the design modules for execution. First module is Generate Network. In this module, we component of the custom network simulator built using Python. Its purpose is to create a simulated network environment that represents a Spanish metropolitan network. The module randomly generates 20 nodes representing different locations and assigns specific attributes to these nodes, such as type of nodes, which are AMEN, MCEN, MCENB, their positions, and other characteristics required for the simulation. Next one is Initialize Network. In this module, it is responsible for initiating the network after it has been generated. In this phase, the module identifies the metro core edge nodes with backbone, which is MCENB, based on criteria such as proximity to other nodes or specific network metrics. The nodes that are closer to the MCENB are designed at metro core edge nodes. The access metro edge nodes, which are AMEN, are also identified and defined. This initialization is crucial for setting up the network's hierarchical structure and creating the necessary node relationships. Third one is Run LA-ML-SCA algorithm. This module is a vital part of the project as it implements the latency-aware multi-layer service chain allocation, which is LA-ML-SCA algorithm. This algorithm is designed to reduce latency in the SDN NFV network. It takes the generated networks as input and works on the principle of selecting the shortest path for each service request by sorting all service requests in descending order. The algorithm iterates through each request and calculates the shortest path using a latency-aware criterion. It then chooses the path that results in the shortest latency for serving the particular request. Fourth module is Algorithm Execution Time Graph. This module is used to analyze and visualize the performance of LA-ML-SCA algorithm. It plots a graph where the x-axis represents the number of service requests being sent and the y-axis represents the execution time taken by the algorithm to find the shortest path for each request. This graph allows the project to evaluate algorithm's efficiency and how it performs as the workload increases. By using all these modules in the methodology, we can effectively simulate the network by applying proposed LA-ML-SCA algorithm and assess its impacts on latency reduction in metropolitan networks. For execution, first open the code folder So this is the code folder and this is the main code file. And this is the run.bat file. Instead of executing the project in command line interface, we have created Windows batch file for execution. So double click on it for execution. This is the graphical user interface of the project. With this, we can interact with the program. This is created by using Tkinter library in the Python. Now click on the button Generate Network to create SDN NFV network. Here, 20 nodes are displayed at random position. All red color nodes are AMEN nodes and blue color node is MCENB node. Now, we need to calculate MCEN node. So to do that, click on the button Initialize Network button. Here, all nodes are closer to MCENB, which will become MCEN node. AMEN sends a request to MCEN and MCEN sends request to MCENB. So here all green color nodes are MCEN nodes and all big circles represent regions. And now click on Send Request to MCEN node. We'll select any node from drop down box. So here I will select node 4 and click on Run LAML SEO algorithm. Here I selected node 4. By this, it has the shortest path as node 5 and the related MCEN37 node is this one, and this will connect to MCENB node. And similarly, we will be applying other node IDs also, and click on Run LAMCL. So for this, here for node 9, the shortest path is node 11, and for this it will be connecting to MCEN node, and with this we will be connecting to MCENB node. Now click on the button Algorithm Execution Time Graph. Here in this graph, x-axis represent number of requests sending and y-axis represent algorithm execution time to find the shortest path for that request. Here the shortest time is 0.0010 milliseconds. So close this graph, exit the simulation. Conclusion: the project introduces an innovative approach to reduce latency in metropolitan networks using SDN and NFV. The proposed LAML SEO algorithm dynamically allocates resources and selects the shortest path for service requests, resulting in improved network efficiency and reduced end-to-end delay. The custom Python-based network simulator validates the effectiveness of the approach, showing promising results in enhancing user experience for data-intensive applications. However, implementing this dynamic approach may entail increased financial costs due to the deployment of additional edge nodes. Overall, the project contributes valuable insights towards optimizing resource allocation and addressing latency challenges in modern metropolitan networks.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.